All right, welcome back. Glad you survived that first video. Ouch. All right, so they give us cosine is equal to negative 2/3. They tell us tangent is positive, and we're wanting to find sine. All right, that's going to be our goal, to find sine squared. So first thing I want to do is figure out what quadrant I'm in. All right, because cosine is negative, that's my x values. So I know I'm in either quadrant 2 or quadrant 3. And it says here tangent is greater than 0. That means tangent is positive. Right? Tangent is only positive in this quadrant and this quadrant. So that's where I'm at. I'm in quadrant 3. All right, so I know whenever I find sine, because I'm in quadrant 3, I know my answer is going to be negative. All right, because sine and cosine are negative, that's why tangent's positive. Let's solve it first, just using the basic little triangle method. So I'll label this to be my theta, my angle. All right, I know that cosine is equal to adjacent over hypotenuse. So I got 2 and 3. And I just need to solve for this missing side. So I'll use Pythagoras real quick. Let's see here. Hypotenuse squared is equal to a leg squared plus the other leg squared right there. 3 squared is 9. 2 squared is 4. All right, move my 4 over, I get a 5. All right, square root both sides, and I get square root of 5. There it is. All right, just from this, I know that sine of theta is going to be square root of 5 over 3. All right, opposite over hypotenuse. And it is negative. Yeah, I know because I'm in the third quadrant that sine and cosine both are negative. Now, if we wanted to find cosecant, we would just flip this. All right, it still have the same positive and negative sign as this one. If we wanted to find secant, we would just flip this. You know what? I guess real quick, let me do tangent real fast. Wasn't planning on that, but tangent is sine over cosine. Oh gosh, what am I thinking? Tangent, I already got my triangle. Tangent is equal to root 5 over 2. Golly, opposite over adjacent. That just makes it so much easier, doesn't it? But I could also stack this complex, this fraction, on top of that fraction. That would also give me the same answer. All right, let's solve it using the identity. Cosine is equal to negative 2/3. I'm going to solve for sine. So I'm going to square both sides. So I get cosine squared. And this side, whenever I square it, I'm going to get a positive 4 and a positive 9. Right? All right, I'm going to replace cosine. See, cosine squared is equal to 1 minus sine squared. So I'm going to replace this with 1 minus sine squared. 1 minus sine squared is equal to 4/9. Okay. I'm going to move my 1 over. I get negative sine squared. If I move my 1 over, it's going to be 4/9 minus 9 over 9. So I'm going to get negative sine. 4 minus 9 is negative 5. The denominators are the same, so I get a 9. I can ignore the negatives. Just divide out the negative if you want to. And then from here, I would square root both sides. So when I square root, I'm going to get sine, and I'm going to get square root of 5 as my top part, and the square root of 9 is my bottom part, which is 3. There it is. Woo. All right, last one. Promise this one's faster. Well, I say that. I shouldn't promise stuff like that. All right, sine of theta is equal to 1/2. And it tells us that theta is between pi over 2 and pi. So this actually kind of spells out what quadrant we're in. So here's pi over 2, and here's pi. Since theta is in between those two, I know I'm in quadrant 2. All right? I have to be in quadrant 2, which means my cosine is going to be negative. Sine's positive there, cosine's negative. You might already know what the answer is. This is actually on the unit circle, right? This one's a special one that's on the unit circle. Building a triangle, I could do theta's right here. This would be my opposite. This would be my hypotenuse. And I could solve for this one using Pythagoras here. I'd do 2 squared is 4. That's equal to 1 squared plus my missing side square. Subtract the 1 from both sides. I get 3 equal x squared. So root 3 is equal to x. All right, so that would be my missing side here, root 3. And then cosine's a sinh. Cosine would equal the adjacent over the hypotenuse. Root 3 over 2. Good job. Oh, and it's, golly, almost forgot. It's negative. Yeah. Because I actually built this triangle. I'm supposed to be building this triangle in quadrant 2 somehow. All right. All right, real fast. Sine squared plus cosine squared equals 1. All right. Let's take my original equation here. Oh. All right, to solve for cosine using the identity, I'm going to square both sides. I get sine squared. Over here, I'm going to get 1/4. Sine squared is the same as 1 minus cosine. 1 minus cosine squared. All right, equal to 1/4. This time, I'm gonna move my 1/4 over here. So subtract 1/4 from both sides, and that's going to be 3/4. And I'm going to move my negative cosine squared over to this side. So I get cosine squared over there. So I kind of shuffled them around a little. Square root. You're going to get square root of 3 on top and the square root of 4 on the bottom, which is 2. And then, of course, it's negative. Bam. Wasn't too bad. That's it. We solved for cosine. Good job, guys.